6.6. So when we first started the graphic organizer, I think we talked about a trapezoid, what a trapezoid was. Well, let's just make sure that we all have that. A trapezoid is a quadrilateral. It shows that on our graphic organizer. They're related. A trapezoid is a quadrilateral with one pair of parallel sides. So on your drawing, and we're going to label some other things on our drawing there. So our drawing looks something like this. We have a pair of parallel sides, like so. We call the sides that are not parallel, we call them legs. So that's a leg, that's a leg, and then we call the parallel sides bases. So we have two legs and two bases, and then we call the angles inside our trapezoid the base angles. So I have to decide which base we're talking about, and then we can talk about then we can describe the base angles. The short base, the long base. All right, so we're good with a trapezoid. Other than having a pair of parallel sides, there's not a lot that's special about a trapezoid. All right, now we're going to move down to isosceles. An isosceles trapezoid. So, with an isosceles triangle, what was it special about an isosceles triangle? Two of the sides were the same. That's exactly the same for an isosceles trapezoid. The legs are congruent. So on your graphic organizer, I think your trapezoid looks like this. So these are our parallel sides, our bases, and these sides would be congruent. So that's what makes an isosceles triangle. The legs are congruent. But a couple of other things, nice things happen. The base angles, pairs of base angles are congruent. So that means that this angle here would be congruent to this angle here. And this angle, the other base angle up here, would be congruent to this base angle up there. And we can't draw all this stuff in here, but a couple of other things that happen with isosceles trapezoids. The diagonals are congruent. And consecutive angles on a leg, consecutive means what? Next to each other in a row. So consecutive angles on a leg are supplementary. And excuse me, supplementary means they add to 180. So on this, if we call this angle A and angle B, we'd say the measure of angle A plus the measure of angle B is 180 degrees. Right, so the parallel sides are the bases. So we don't call them legs. The parallel sides we call bases. So along the base, on the isosceles trapezoid at least, those consecutive angles are congruent. So angle A and angle B add up to 180. These two would add up to 180, but along the bases they're congruent. And we could also figure that out because these two segments are parallel. There's our transversal, so what kinds of angles are those for these two parallel segments? They're between the parallel lines and on the same side of the transversal. So they're same side interior angles and same side interior angles are supplementary. All right, so we good on trapezoids. Did I tell you guys a few years ago I had a student from the UK and we were talking about trapezoids and said, what is a trapezoid? Do you mean trapezium? In the UK they call trapezoids trapezium.
Oh, that's awesome.
Yes, that's what we mean, trapezium. All right, we good? All right, kites. Kite is a quadrilateral, so you can see that on your graphic organizer, on your family tree there. Kites have two pairs of consecutive sides congruent no opposite sides congruent and no parallel sides. So on your graphic organizer, if we were to draw some marks on our kite, when I draw kites they always turn out crooked. So pretty good. So consecutive, two pairs of consecutive congruent sides. So those two would be congruent. And those two would be congruent. The opposite sides are not parallel. And the opposite sides are not congruent. A couple of other things happen with the kite. The diagonals are perpendicular. And perpendicular means 90-degree angle. So if you're putting your labels on the outside of your shape, you could draw your diagonals in there. Otherwise, you can make a little sketch if you want. So our diagonals are perpendicular, so that's a 90-degree angle. The long diagonal bisects the short diagonal. So these two segments would be congruent. And the long diagonal bisects the angles of the kite. So these angles would be congruent. And these two angles would be congruent. So it cuts those angles in half. So those are the special things that happen in a kite. We'll do a little bit with kites. Mostly we'll work with parallelograms, rhombuses, squares. All right, questions on our labels. Everybody have your graphic organizer filled? All right, so what I want to do next is do a couple of examples that have to do with trapezoids and kites, and then talk about, right at the end, we'll talk about trapezoid mid-segments. All right, so let's look at some examples. So these probably will need to go on a separate sheet of paper, or if you have room on the back, they could go on the back. All right, so this is an isosceles trapezoid. So the problem tells you that. And we want to, I'm going to call this A, B, C, and D. And we're going to say this is 75 degrees. And we want to find the missing angles. So since this is an isosceles trapezoid, which one's the easiest to find? Angle A. And what would angle A be? 75. The base angles are congruent. So we know that this is 75 degrees. And how are we going to figure out angle D and angle C? B and C are supplementary. So if I subtract 75 from 180, and what do we get? Someone said it, 105. So the measure of angle D and the measure of angle C, because those two are the same, base angles are the same, are both 105 degrees. And what do all the angles inside a quadrilateral add up to? 360. So if these two add up to 180, and those two add up to 180, then we're all set. Everything adds up to 360, and everything is nice in our trapezoid world. Speaking of angles, adding up angles, our class on the quadrilateral puzzle, for the most part, we did really well. I was impressed with how many of us got all of the angles in the quadrilateral puzzle. All right, let's look at another one. This one a little different because it has to do with a triangle. All right, I'm going to say this angle is 32 degrees. That's X degrees. That's Y degrees. And we're going to say triangle ABC is isosceles. We want to find X and Y. So what are we going to do here? Well, if this triangle is isosceles, what do we know about that side and that side? They're the same. So those two sides have to be the same. So what does that tell us about these two angles? They have to be the same, right? The base angles of an isosceles triangle are the same. So that angle is Y degrees. So now we have a problem kind of like our opener, right? What do all the angles inside triangle ABC have to add up to? 180. So I can say 32 plus Y plus Y, so plus 2Y equals 180. And that'll let me find angle Y. Subtract 32, I get 2Y equals 180 minus 32, 148. divide by 2, and I get y equals 74 degrees. So there's 74 degrees. There's 74 degrees. And now let's look at angle x and angle y. What has to be true about those two? They have to be supplementary. These are parallel lines, same side interior angles, so those are supplementary. So 180 minus 74 equals 106. So x equals 106. We started off working with a triangle, ended up working with trapezoid or just a parallel segment. Questions there? Okay. Let's look at a problem that has to do with a kite, and then we'll talk about mid-segments. So here's my kite. And I'm going to say this is 40 degrees. This is angle 1, and this is angle 2. If I measure angle 1, measure angle 2. All right, so we know we have a kite. So what's the easiest angle to find here? Measure angle 1, what does it have to be? 90, right? Because these intersect at right angles, so that one's 90. So the measure of angle 1, that's an easy one, 90 degrees. Well, how are we going to find measure of angle 2? Right. So all of these in the triangle have to equal 180. We know that the long diagonal bisects this angle, so that's angle 2 also, and all of those have to add up to 180. So I have a 90 plus 40 is 130. So 180 minus 130 is 50. So the measure of angle 2 equals 50 degrees. All right, questions there? All right, let's talk about trapezoid mid-segments, and then we will be done. All right, so let's draw a picture. What we mean by a mid-segment. So here's my trapezoid. Doesn't have to be isosceles, it can be any kind of trapezoid. So here are my bases, and I'm going to call this trapezoid A, B, C, D, and I'll call this point E and point F. So do we remember with triangles, what made a segment a mid-segment of a triangle? What does the mid tell us about the mid-segment? It's in the middle. It's a segment in the middle of these sides. So the mid-segment joins the midpoint of the legs. So point E and point F are the midpoints of the legs. So that tells us that that segment is congruent to that segment because that point is right in the middle, and that segment is congruent to that segment. And do you remember what we said about the mid-segment of a triangle, how it was related to the base? It's parallel. So the mid-segment is parallel to the base. And it's parallel to both bases. So it's parallel to the bases. And do you remember how the length of the mid-segment compared to the length of the base of a triangle? It was half the length of the base. So for a trapezoid, because we have two bases, we have to take those into account. So what we do is we add the bases together and divide by 2. So the length of the mid-segment is half the sum means add together, half the sum of the base lengths. So if we were to write symbols, we would say segment BC is parallel to segment EF, the mid segment there, which is parallel to segment AD. And we would say that EF, the length of EF, is the length of the bases added together, BC plus AD, divided by 2. So I add the bases together and then divide by 2. And here we're saying EF is the mid-segment. It's very similar to what we talked about with triangles. The mid-segment is parallel to the bases. And its length, we add the bases together, divide by 2 to get the length of the mid-segment. So it's the average of the lengths of the bases. All right, questions there? All right, let's do one problem that has to do with the mid-segment, and then we'll be done. All right, 6x minus 12, 2x plus 10, and 18. Trapezoid mid-segment example. Yep. And I'm going to say that segment TU is the mid-segment. We want to find x. We have a trapezoid, we have the mid-segment, we want to find x. So, how are we going to set this up? So, the mid-segment is the one base, plus the other base, divided by 2. So the mid-segment is 2x plus 10, and that is 6x minus 12, plus 18, divided by 2. Now what are we going to do here? How do we deal with this 2 here? Multiply everything by 2. And when I multiply this side by 2, I have to remember to multiply everything by 2. So I'm distributing here. So I get 4x plus 20 equals, and when I combine like terms, 6x plus 12, or minus 12 plus 18. 6x plus 6, minus 12 plus 18 is 6. And now we're set, right? Get x by itself. So we get 20 equals 2x plus 6. Subtract 6, 14 equals 2x, and divide by 2, and x equals 7. Popular number for x today. Anybody see a different way we could have done this from this point instead of multiplying by 2 on both sides? Since each of these, since 6, 12, and 18 we can divide by 2, I could have just divided everything here by 2. So I divided the 6 by 2 and got 3, divided the 12 by 2 and got 6, divided the 18 by 2 and got 9. And that would also simplify to, that would simplify to 3x plus 3. So, and you'd end up in the same place. All right, questions? Okay. So here's the homework. Hello.